Hello everyone, in this video I'm going to share about armature winding of DC machine. Okay, armature winding of DC machine. Okay, in the previous video we learned about field winding. Okay, at this part, stator part. So in this video we are going to discuss about armature winding. Armature winding is at rotating part. Okay, this part, rotating part. Okay, in rotor we have a commutator. This we call commutator segment, and also poles. So this pole we call pole, and the commutator and the pole will be connected by copper wire. This copper wire. This copper wire. Okay, copper wire. Okay, all this we call armature. The assembly of between commutator and rotor and this copper wire. So all we call armature winding. Okay. Delete first. Let me delete. Okay. Okay, the commutator is connected to the slot iron core. Okay, this copper will connect the rotor and the commutator. The iron acts as magnetic conductor. Okay, this iron will act as magnetic conductor. So we know that for the stator, they will rotating part. Let me delete all the marker first. Okay. Okay. Stator is the winding at the stator we call field winding. This field winding, the wind at this pole. So in this case we have 4 pole. So when this pole produce electric fields, and then this rotor rotate inside this stator. So what happen is, so we know that rotor they have a conductor wire here. This conductor wire will cut the magnetic field inside the rotor. So based on Faraday's laws, that when this conductor cut the magnetic field here, so they will produce induced EMF. So induced EMF will be produced at rotor part. Then the induced EMF the current will flow from this rotor part through the conductor, go out through the brushes. Sorry. Okay, brushes here. Brushes contact with conductor, with commutator, and the current will flow to the external circuit current. Okay, will flow the induced current, at this rotor, at the rotating part. Okay, so there are a few type of winding. A few type of winding. So in this video we learn about 3 basic type of the winding, named as lap winding, wave winding, and also frog leg winding. Okay, the first winding is lap winding armature. Okay, in lap winding armature, we can see that they are okay. The first one is the winding for the first coil is gray color. Okay, this first coil. The second coil is a red color. So red color is second coil. We can see that there is overlap between blue coil, gray coil and red coil. Overlap is here. This part, this overlap. Okay, that part is overlap. So we call that lap winding armature. Okay, like this. Let me show how the winding, how the overlap, or how the lap winding look like. Okay, let's say we use red color. We use blue color for first winding, for first coil. So this one is first coil start from this contactor. Contactor go here, go to the poles, and then this coil move back to the pole. So we can see that there are two poles here, first pole and second pole. This one is first coil. So the second coil is start from here, so they will move, continue here, and go back here. So we can see that this pole, there is overlap at this pole. Okay, overlap winding, the coil 1 and coil gray and coil red is overlap there. So that's why we call lap winding armature. Okay, this type of winding is for low voltage and high current. Okay, we can see that the winding is like this. Okay, sorry. The winding will be from this one, go here, first winding, first coil, then second coil is okay, we can see that there's overlap here. So in this winding we have 1, 2, 3, 4 parallel winding. So for parallel, we know that for parallel there will be added current. So we have current 1, I1, I2, I3 and I4. Okay, we have 4 current here. So the current will be added together. So it means that this type of winding produce high current, will produce high current. Okay, the summation of current. So normally common use this type of winding is for starter motor. We know that to start the motor we need high current, so use at a starter motor. Okay, the winding are connected in parallel, so current. Okay, I will explain this. Okay, number of current pass is equal to C is number of current pass equal to 2P, because we have one pole we share each other, so that means we have 2P, 2 times P. Okay, that's one for lap winding armature. Second type of winding is wave winding. Okay, let's look at this connection. So first we connect from the commutator, this coil go around poles, and then complete for one coil. So the second coil just continue the first coil. Okay, this one is second coil. Okay, from this one you can see that first coil. Okay, ending here, one coil. The second coil is start from end of the first coil. Okay, this one we call wave winding. One end of the coil is connected to the starting end of the other coil. Okay. Okay, for this case we can see that this is the diagram of wiring. So like in series, because just in series, so that means our coil, our inductance is in series. We have series inductance. So, okay, you can see that from this figure, inductance in series. 1, 2, 3, 4. Okay, inductance in series. So that means there will be the generated EMF will be added together. So let's say this one is E1, E2, E3, E4. So in series, so they will produce high voltage. So the total voltage at the end of the connection is voltage. So the total, the voltage. So high voltage and low current. Just 1-2 wire only. Because in series, so that means same current for series. So low current. The previously is in parallel. So in parallel, we know that for parallel connection, we have to add current. The voltage is same. Okay, the previous one parallel, so we add current. The second one is in series. The wave winding in series, so we add generated EMF. Okay. The last one is the combination of the both winding we call frog leg winding. Frog leg winding. So the combination series. This one is in series. Series winding, or we call wave winding in series wave. Then in parallel, this one is parallel. Okay, parallel. Parallel we call lap winding. So combination of lap and series winding. Lap and wave winding. Okay, this one is most used in practical nowadays. Okay, due to they have combination for both winding, so that means they will produce moderate current and moderate voltage. Okay, so as a summary for this video, the amount of generated voltage at this our rotor will be the generated voltage will be produced at the rotating part. So the amount of voltage or current is depend on the winding. If we use lap winding, we can produce high current. High current produced at our rotor. If we use wave winding, we can produce high voltage at rotor. This one is we call brushes. These brushes to connect the commutator with the additional external circuit. Okay. Okay, brushes connect the commutator to the external circuit. So the induced voltage or induced current will flow through these brushes, these two brushes will flow to our external circuit, whether we can use to generate to store the generated current here, the current of voltage there. Okay, that's all. Thank you.